Alright, let's do this. Now we're finding a second derivative. Second derivative of y with respect to x when the equations are given in parametrized form. Piece of cake. I think this is so easy I might even be able to do it with just one hand. This one, we don't need it. Look. First thing we do is we say, alright, we need to find dy dx. That's the first step before finding second derivative. The trick to this is to divide top and the bottom by a dt, and from here we say that okay, if x is equal to 5t to the third, then I could slap a d on this side. Well, I could slap a d on a different color. I could go with blue, for example. I slap a d on this side. As long as I slap a d on that side, it'll be alright. And then this will give me that dx is equal to 15t squared dt. And so this gives me that dx dt is equal to 15t squared. Similarly here, dy dt, I can slap a d dt on this side, d dt on that side. Why not? I could also slap a d on both sides, but same difference. This will give me 2 times the cosine of t. So I've got my dy dt, that's going to go over here. I was almost going to use this hand, but I said I'm not going to. Watch this, how easy this is. This becomes 2 cosine t, that would be the numerator, and the denominator would be 15t squared. And so we have that dy dx is equal to 2 times cosine t over 15t squared. Now what we set out to find was the second derivative. What we've got here is the first derivative. So to finish it off, what we could do is we could slap a d dx on this side, so long as we slap a d dx on that side. On the left hand side, that would give me, the second derivative of y with respect to x. On the right hand side, it looks like I got to do quotient rule. The derivative of the top, that would be d dx of 2 cosine t times the bottom, 15t squared, minus the top times the derivative, no hands, the derivative of the bottom, d dx of 15t squared, all over the bottom square. Alright, so then we continue with this second derivative of y with respect to x squared. That would give me, alright, what is this guy? The derivative of cosine, that would give me 2 sine t times d dx of t. That's that piece. Times 15t squared minus 2 times cosine t. That would be equal to 2 times 15 times t times d dx. That would be d dx of t. Okay, this is chain rule. This is the derivative with respect to x, and this is t. That's why you need the dt dx at the end. This is equivalent to dt dx, same as that. All that, of course, over 15t squared. Now, you're basically done except for this piece right here. You need a dt dx, and you need this dt dx. Where would you get that from? Well, of course, we have an xt relationship here. We knew that x was equal to 5t to the third, and we knew that we could slap t to the third, and we knew that we could slap a d on both sides, which we did earlier, but it was so fun, we're doing it again. So now that will give us that dx is equal to 15t squared dt. In this case, I'm trying to figure out what dt dx is equal to. So in this case, I'll divide both sides by that, and by that I'll get that 1 over 15t squared is equal to dt over dx. Or I could have just flipped this one, but it was so fun to do this work that I just did it again. So now I've got an expression for my dt dx, which would go right here, and it would go right here. So the final answer would be the second derivative of y with respect to x squared, or sorry, second derivative of y with respect to x, and that's equal to, whoa, I didn't realize I just moved it. That would be 2 times sine t, that's this piece, times dx dt, so it would be times 1 over 15t squared times 15t squared minus 2 times cosine of t times 2 times 15t, again dt dx, 1 over 15t squared, all that over 15t squared square. See that? QED. That's why they pay me. Alright, peace. We'll see you guys